Welcome back. This is section 5.1, the unit circle. So what we're going to look at in this section is now an organizational way that we can actually try to remember some of those special values that we looked at back in chapter 6. Okay, and so we're going to start this with basically what is the unit circle? How do we find points along that unit circle? And then eventually, how is that related to all of those special angles that we looked at in chapter 6? All right, so first off, the unit circle. Okay, so when we talk about a unit circle, we're talking about a circle here that has a radius of 1. So notice here, the equation of that circle is going to be x squared plus y squared is equal to 1, okay, because we have a center at the origin and we have a radius of 1. All right, now we want to show here that the point, square root of 3 over 3, square root of 6 over 3 is on that unit circle. So the way we're going to do that is we're actually going to take our formula, x squared plus y squared equals 1. And we're going to substitute those two x and y values into that formula. So we have an x and y. So that's going to give us square root of 3 over 3 squared plus square root of 6 over 3 squared. And we're asking ourselves, is that going to be equal to 1 now? Now, when we square a fraction, we can square the numerator, square the denominator. So square root of 3 squared just gives us 3. 3 squared gives us 9. Over here now, the square root of 6 squared is 6. Square root of 3 squared is also 9. And when we add these two fractions, we already have a common denominator, so we can add their numerators. 3 plus 6 is 9 over 9. And that is actually equal to 1. And so that shows there that that point is going to be on our unit circle. So in the homework, there could be questions as simple as, is this point on the unit circle? And so all you have to do is substitute that point into that equation, make sure it's equal to 1. If it's equal to 1, it's on the unit circle. If it's not equal to 1, then it's not on the unit circle. All right, now this next one, they're giving us part of a point. So we've got square root of 3 over 2 as our x value. We're asked to find the y coordinate as long as this point is on the unit circle in quadrant 4. So again, we're going to use our equation, x squared plus y squared equals 1. We're going to substitute what we know, which is the x value this time. We have square root of 3 over 2 squared plus y squared equals 1. And at this point, we can actually solve this equation for y. So I'm going to start by squaring this x value. So square root of 3 squared should give us 3. 2 squared is 4. Now I need to get my y by itself. So I'm going to subtract 3/4 from both sides. 1 minus 3/4 gives us 1/4. And now I can just take the square root of both sides. And so y equals, and just don't forget, when we take a square root like this, we have to remember a plus or minus. So we're going to have a plus or minus. Square root of 1 is 1. Square root of 4 is 2. So we get plus or minus 1/2. Now, that means there's two possible y values that could work in this ordered pair. However, they tell us that our point is in quadrant 4. And so if you think about quadrant 4, x values are going to be positive, y values are going to be negative, which means we're going to take the negative value here. And so our answer is y equals negative 1/2. All right, now terminal points along our unit circle. So just like we had terminal sides and an angle back in chapter 6, now we're going to have what we call terminal points along the unit circle. So notice here, if we have a t value that's greater than 0, we're going to go in a counterclockwise direction, just like our angles did. But now we're going to end up at a point along the unit circle that has an actual x and y coordinate. Our t value is negative, less than 0, then it's going to go in a clockwise direction instead, okay, just like our angles did. Now, when you look down at the bottom, you'll see that a t value of pi over 2 actually has a terminal point up at the very top at 0, 1. If you recall, pi over 2 is like 90 degrees in radians. Okay, and so in this case, that's going to give us a point that's right up there where 90 degrees would be when we were dealing with our quadrants and our angles earlier. And a t-value of pi now along the unit circle, it's going to give us a point at -1, 0. And again, that's halfway around our unit circle. 3 pi over 2 is 3/4 of the way around, and so we get a point at 0, -1. And then 2 pi is a complete revolution. We're going to go all the way around the unit circle now, and that gives us a point all the way back at 1, 0. So notice here, as long as we are on the unit circle, these t values, which are just distances, arc lengths along the unit circle itself, they're going to have the exact same value as those angles would that we looked at in chapter 6 at those same points. All right, so we want to find a terminal point on the unit circle for each of these t values here. So 3 pi, first thing we're going to do is we're going to locate where would 3 pi be on our unit circle. Well, 3 pi is bigger than 2 pi, so I'm definitely going around a full revolution. Would be 2 pi. And if, because we're going 3 pi, we're going 1 pi beyond that. That's going to be another half of a revolution. We're going positive direction like this, all the way around, plus another pi. And so 3 pi is going to be right here. And so now the terminal point should be at -1, 0. Our x value is -1. We're on the x-axis, so the y value is 0. And so this has a terminal point of -1, 0. Just remember, we're on a unit circle. The radius has to be 1. That's why that x value has to be -1 here. All right, now the next one. This time we're going -pi. Well, because we're going negative, we know we're going to go in a clockwise direction. Pi is only going to take us halfway around, though. So we're going to go around like this, and we're going to end right over here. So again, we need to think about our terminal point. Since our radius of our unit circle is 1, this is actually going to be -1, 0 again. And so we get the exact same terminal point we got for the first one. And then our last one here, -pi over 2. So negative, meaning we're going in a clockwise direction. Pi over 2 is only a quarter of the way around now. So we're going to end up down here. So this time, the x value is going to be 0. Our y value is going to be -1. And so our terminal point, 0, -1. So just keep in mind here, any of these that land on one of the axes is going to have a value of either 1 or -1 because the radius of that circle is 1, and the other value has to be 0 if it's on the axis. All right, now, here are some of our special values that we looked at in chapter 6. Okay, now we're talking about them in terms of distances along a unit circle, but remember we already said that the angles there should be pretty much a match. And so pi over 6 radians is basically going to be the same terminal point where pi over 6 would be on our unit circle. And we can see there that the ordered pair gives us square root of 3 over 2, 1/2. And so there's our terminal point at pi over 6. At pi over 4, we have a terminal point of square root of 2 over 2, square root of 2 over 2. The x and y values are the same there. And at pi over 3, which would be just like 60 degrees, that gives us 1/2 square root of 3 over 2 as our terminal point. And we already talked about pi over 2 gives us 0, 1. And then if we go all the way around, 0 or 2 pi gives us a point 1, 0. Now, you are going to want to start to memorize these ordered pairs because, again, they're going to relate to those values that we looked at in chapter 6. And this is now an easier way to help us remember what these values are. And if we can just remember what the values are in the first quadrant, then we can actually figure out what the values are in all 3 other quadrants just by making certain values negative. So the way I'm going to remember this, if you notice all of your denominators here, every single one of them is a 2. Okay, so I know every one of these fractions is something over 2. Now I'm going to start with my y values, and I'm going to work counterclockwise. So notice here, the numerator is 1, 2, 3. Okay, so if you start from the y values and you work counterclockwise, we're just doing square root of 1, which is 1, square root of 2, which we can't simplify, square root of 3, which again we can't simplify. So if you can just remember square root of 1, square root of 2, square root of 3, that'll give you the numerators of all the y values. Then the x values coming back the other way, same thing. We have a square root of 1, square root of 2, square root of 3. Square root of 1 just simplifies to 1, okay, but the other two stay square root of 2 and square root of 3. So again, all of your denominators are 2's, 1, 2, 3, 1, 2, 3, and that'll give you all the numerators that you need for those points. And at that point, it's just a matter of remembering all of those special angles. Pi over 6 is 30 degrees, pi over 4 is 45 degrees, pi over 3 is 60 degrees, and then we'll work on the other quadrants as well. All right, so we want to find the terminal point determined by each of these t values again. So the first one we're looking at is negative pi over 4. So again, I'm going to sketch this. Now, because it's negative, we know we're going to go clockwise. Pi over 4 now is like 45 degrees, right? So we're only going halfway in between where 0 and 90 would be. We're going to be halfway into this quadrant right here. Now, what I'm going to do to figure out the value of the ordered pair, the terminal point here, is I'm going to think about what would be the other value in the first quadrant that we just saw on our unit circle. So if I were to go halfway around in my first quadrant, we know that's positive pi over 4, and its ordered pair was square root of 2 over 2, square root of 2 over 2. So now down here at negative pi over 4, we just have to think about it's a reflection now over the x-axis. It's in the fourth quadrant. So the only thing that's going to change is now my y value has to become negative. X value is going to stay exactly the same. Y value becomes negative. And so this gives us square root of 2 over 2, and then negative square root of 2 over 2. And so my terminal point square root of 2 over 2, negative square root of 2 over 2. So again, if you can just remember those values from the first quadrant, all of these other values that we find, no matter which quadrant they're in, we can think of as reflections, and then we can just think about which values are going to have to become negative. All right, now 3 pi over 4. Right, so 3 pi over 4, definitely bigger than pi over 2, smaller than pi though. In this case, is exactly halfway between 1/2 pi and pi. So it's going to take us into the second quadrant. Again, positive, so we're going counterclockwise. We're going halfway between pi over 2 and pi now. So again, I need to think about what would be the point from the first quadrant that would help us to identify what that ordered pair is going to be in the second quadrant now. Well, the point halfway in the first quadrant again is that pi over 4 that we just looked at. Its ordered pair is square root of 2 over 2, square root of 2 over 2. And so this time, if I move that point to the second quadrant, now we have a reflection over the y-axis. My x value becomes negative, y value stays positive, and so this is actually going to give us negative square root of 2 over 2, positive square root of 2 over 2. And so my terminal point this time, negative square root of 2 over 2, and positive square root of 2 over 2. All right, now our last one, negative 5 pi over 6. Again, we need to think about where that's going to be located. Negative meaning we're going in a clockwise direction this time. 6 pi over 6 would be 1 pi, so we know we're not quite to pi yet, but it's going to be pretty close. Okay, so we're going to go around. We're going to end up right here in the third quadrant. This is going to be negative 5 pi over 6. Now, again, I need to think about those ordered pairs from the first quadrant that would give us a reflection now that would give us this ordered pair. The point that we can reflect then is going to be positive pi over 6. Now, that ordered pair, when you look at it, should be square root of 3 over 2 and 1/2. Now this time, because we've moved to the third quadrant, what's going to happen is both the x and the y values have to become negative. And so this point down here should give us negative square root of 3 over 2 and negative 1/2. So our terminal point, negative square root of 3 over 2, negative 1/2. But again, in general, sketch the t value that's given, then figure out what's the t value from the first quadrant that would align with that point, figure out the ordered pair at your t value in the first quadrant, and then adjust your signs based off the quadrant that you're in. All right, now reference numbers. So if you remember back in chapter 6, we had what were called reference angles. Well, now we have something very similar with these t values we call a reference number. And that's exactly what we were doing on the previous slide, is we were figuring out what is that angle from the first quadrant. That's going to be our reference number, so that we can figure out the ordered pair and then adjust the signs. Okay, so just remember, just like reference angles were always measured to the x-axis, same thing with these reference numbers. We're going to measure from the terminal point to the x-axis. That's going to give us a t-bar value. That's going to be our reference number. But again, it's identical to what those values were from the first quadrant, so that we can then figure out what those ordered pairs are going to be. All right, now we want to find our reference number for each of these values of t. Okay, so not finding any terminal points yet, just finding reference numbers. So first thing I'm going to do, I'm going to locate where 5 pi over 6 is. This time we're going counterclockwise because we have a positive value. 5 pi over 6 again is just a little bit less than pi. It's going to come around to here, right here. Now, what we're trying to figure out is the reference number. So I want to know what's the distance now to the x-axis. Oh, remember we just said this is pi. And so if this is 5 pi over 6, all I have to do is take pi minus 5 pi over 6. Find your common denominator. That's going to give us 6 pi over 6 minus 5 pi over 6. And that's pi over 6. And so our t-bar is going to be pi over 6. Now, again, that's exactly what we did on the previous example when we were trying to find those ordered pairs from the first quadrant. Remember that pi over 6 would now be the reflection over the y-axis. And so if we know the ordered pair there, then we can find the ordered pair at 5 pi over 6 as well. All right, now our next one, 7 pi over 4. Okay, now I know that 8 pi over 4 would be equivalent to 2 pi, so I'm actually getting pretty close to 2 pi here. I'm almost going a full revolution, but I'm going to be pi over 4 short of that. So I'm going to go around. I'm going to be halfway into this fourth quadrant here. Because again, 8 pi over 4 would be 2 pi. I'm going 7 pi over 4 instead. Now again, we're looking for the reference number, so I need to know what's the distance now back to that x-axis. Well, we said this is going to be 2 pi. So if I just do 2 pi minus 7 pi over 4, again, we're going to need a common denominator. 2 pi is 8 pi over 4 minus 7 pi over 4. And that leaves us with pi over 4. And so my t bar this time is pi over 4. And again, that would be that point from the first quadrant that's a reflection over the x-axis this time. So again, that's what's going to be useful about these values, is they're going to help us to find those ordered pairs. All right, now negative 2 pi over 3. Now this time we're going clockwise because we have a negative value. 2 pi over 3. 3 pi over 3 would be pi, so we know we're not going halfway. 2 pi over 3 is actually going to put us right down here now. So here's negative 2 pi over 3. Now again, I need to find the distance here to the x-axis, which would be negative pi. And the way we're going to do it this time, because of our negative values, we're going to take negative 2 pi over 3, and we're going to subtract negative pi. And again, the reason for that is negative pi is a smaller value than negative 2 pi over 3. We need to make sure we end up with a positive value overall for our reference number. So that's why we have to subtract in this order. So we have negative 2 pi over 3 plus, so the minus and negative becomes addition, and then pi with a common denominator would be 3 pi over 3. Now negative 2 pi over 3 plus 3 pi over 3 should give us pi over 3. And so our t bar this time, pi over 3. All right, and then finally here we've got 5.80 as our t value. So we have to think about where is that going to be located. Now, the way we're going to do that is we're actually going to think about all of our special values along the axes here, and we're going to figure out what their decimal approximations would be. I'm going to start up here with pi over 2. So we need to take pi over 2 here, and we need to think about what's the decimal value for pi over 2. So I'm just going to put that in my calculator, pi divided by 2, and that gives me about 1.57. Okay, so we know 5.80 now, definitely bigger than that. So I'm going to come over here, and I'm going to say, well, what about pi? Well, pi is one we're probably familiar with. That's about 3.14. And so our 5.80, again, bigger than that value, so I need to keep going. My next value down here, 3 pi over 2, it's going to be approximately 4.71. Again, 5.80, still bigger than that. So now I'm going to come over here and say, well, 2 pi is about 6.28. 5.80 is smaller than that, which means that our t value, 5.80, is going to be somewhere between the 3 pi over 2 and the 2 pi. So it's going to be in this quadrant down here now. So we're basically going all the way around like this to that point right there. So bigger than 4.71, but smaller than 6.28. Now again, to find our reference number, we need to find that distance between the x-axis and our terminal point. So this time our x-axis is at 2 pi. So t bar is going to be 2 pi minus the t value that was given here, 5.80. I'm not going to change that to a decimal. This is an exact value. I'm going to leave my answer just like that. Okay, so unless it tells you to round your answer, just leave it with the pi in the answer because that's now an exact value. All right, now here are steps that we're actually going to follow to help us find basically what we did 2 examples ago. So first thing we want to do, find your reference number. Okay, so we're going to draw out where our t-value is. We're going to find that distance back to the x-axis. That's going to give us our reference number. Then we're going to figure out what's the terminal point at that reference number. So again, these are going to be those special angles like pi/6, pi/4, pi/3 from the first quadrant. That's what we're going to get for these reference numbers. We can then identify what's the ordered pair there. Then our terminal point for t is just going to be that same ordered pair, but maybe with a positive or negative value for your x's and y's, depending on the quadrant that you're in. Okay, so we just identify the quadrant, figure out if x and y are going to be positive or negative, and we adjust the point from the first quadrant accordingly. All right, so here we go. So we want to find the terminal point determined by each of these real numbers. So we're going to start with pi/6. Now, we just did these specific values, finding their reference numbers. So I already know that my reference number for this one was pi/6. We just found that on the previous example. So what I need to think about now is what is the ordered pair at pi/6? Well, pi/6 has an ordered pair terminal point of √3/2, 1/2. Okay. And if you recall, 5 pi/6 was over here in our second quadrant. And so now we just need to adjust our signs for the ordered pair at pi/6. Since we're in the second quadrant, our x value becomes negative. And so our terminal point here should be negative √3/2. But the y value stays positive 1/2. So again, think about your t-value, find its reference number, find the ordered pair at your reference number, and then adjust the signs based off the quadrant that you're in. So let's do 7 pi/4. Again, we already found our reference number on the previous example. That gave us pi/4. Pi/4 is going to be right up here. Its terminal point, √2/2, and √2/2. 7 pi/4, though, remember, all the way around here in the fourth quadrant. And so now if we think about its ordered pair, because it's now a reflection over the x-axis, that means our y value becomes negative, x stays positive. So this terminal point is going to be √2/2, negative √2/2. All right, and then our last one here, -2 pi/3. Remember we just said reference number should be pi/3. Pi/3 is right up here. That's 1/2 √3/2 as our terminal point. -2 pi/3, though, recall, was down here. And so now, because we're in the third quadrant, both the x and the y value should become negative. So this is going to give us -1/2, negative √3/2. So again, just to reiterate those steps, identify where is the original value, find its reference number, find the ordered pair at your reference number, and then adjust the signs based off the quadrant that you're in. All right, so example 7, we want to find the terminal point determined by this t-value. Now, 29 pi/6 is definitely bigger than 2 pi. Okay, so this is going to be more than a full revolution. So the first thing I'm going to want to do here is start to subtract off those revolutions so that I can figure out where this t value is actually located. So start by doing 29 pi over 6 minus 2 pi. Now we need a common denominator. We're going to do 29 pi over 6 minus 12 pi over 6. And when we do that, that should give us 17 pi over 6. Now we just said that 2 pi is equivalent to 12 pi over 6, so 17 pi over 6 is still more than a full revolution. So I'm going to have to subtract again. 17 pi over 6 minus another 2 pi. Again, with our common denominator, that becomes 12 pi over 6. And now we get 5 pi over 6. Now, 5 pi over 6 is less than 12 pi over 6, so now we're within a full revolution, so we should be good to go. So now we can sketch this out. Okay, 5 pi over 6, a little bit less than 6 pi over 6, so that's going to be less than pi. It is positive, so we're going counterclockwise. And so we're going to end up right over here now. Now, remember, our next step is to find our reference number. So I need to figure out what is this distance now between the x-axis and that point. X-axis is pi this time. So we have pi minus 5 pi over 6. We find our common denominator. We get 6 pi over 6 minus 5 pi over 6. And that gives us pi over 6. So this is t bar. Once we have that reference number, remember now we can actually find the ordered pair at the reference number. So our ordered pair this time, square root of 3 over 2, 1/2. And then our last step to find our terminal point here is to now adjust the signs. Because we're in the second quadrant, that means our x value becomes negative, the y value stays positive. So our terminal point should be negative square root of 3 over 2, positive 1/2. So our terminal point at 29 pi over 6 is negative square root of 3 over 2, 1/2. And steps are identical. The only difference now, if you have more than a full revolution, just make sure you subtract off 2 pi until you get down to something that's within 1 revolution. Locate where that is, find its reference number, find the ordered pair, adjust the signs based off your quadrant. All right, so that's all we've got for section 5.1 now. As always, if you have any questions on the homework, please let me know, and I will see you next time.